Disconnects, as mandated by the National Electrical Code, serve the crucial function of isolating electrical equipment, ensuring safety during maintenance or repair operations. Importantly, disconnects themselves do not provide overload protection. Fuses and other overcurrent protection, or OCP, devices safeguard electrical circuits against excessive current, mitigating potential damage or fire hazards. These OCP devices can take various forms, including breakers, relays, or fuses. Distinguishing between fuses and OCP without fuses is important. Fuse protection is a one-time event. When a fuse blows, it requires replacement. Fuses find typical application in scenarios demanding immediate current interruption, for instance, safeguarding motors against single phasing. OCP devices, conversely, can offer automatic or manual reset capabilities. They are commonly employed in situations prone to frequent overloads, such as protecting motors from overload conditions. Fuses are mandated by the National Electrical Code in specific scenarios. Firstly, to protect motors from single phasing, particularly when the OCP setting exceeds the motor's locked rotor current. Secondly, to protect motors from excessive starting current, particularly when the OCP setting surpasses the motor's nameplate full load current. Thirdly, to protect motors from ground faults, particularly when the OCP cannot be set low enough to detect a ground fault. OCP without fuses proves sufficient under certain conditions. Firstly, if the OCP setting remains below the motor's locked rotor current. Secondly, if the OCP setting matches or falls below the motor's nameplate full load current. Thirdly, if a ground fault protection device is already installed. The ultimate decision between employing fuses or OCP hinges on the specific application and the desired level of protection. As a general guideline, consider the following. Firstly, utilize fuses in applications prioritizing immediate current interruption, such as safeguarding motors against single phasing. Secondly, opt for OCP without fuses in applications susceptible to frequent overloads and where automatic reset is advantageous. To delve further into motor protection, let's clarify key terms and concepts. Full load current, often abbreviated as FLC, refers to the steady-state current a motor draws when operating at its rated horsepower and voltage. Locked rotor current, also known as starting current or inrush current, represents the current drawn by a motor when it is initially energized but the rotor is not yet turning. This current can be significantly higher, typically several times the FLC. Single phasing occurs when one phase of a three-phase power supply to a motor is lost. This can cause the motor to overheat and potentially fail. Ground fault refers to an unintentional electrical path between a live conductor and ground. This can create a shock hazard and potentially damage equipment. Overload condition occurs when a motor draws more current than its rated FLC for an extended period. This can cause the motor to overheat and shorten its lifespan. Now let's talk about the National Electrical Code, or NEC, which is a set of standards for safe electrical installations. It provides guidelines for selecting and installing overcurrent protection devices, disconnects, and other electrical equipment. NEC Article 430 specifically addresses motors, motor circuits, and controllers. This article provides detailed requirements for motor protection, including conductor sizing, overcurrent protection, and disconnect means. NEC Table 430.52 provides guidance on the maximum rating or setting for motor branch circuit, short circuit, and ground fault protective devices. This table specifies different percentages of the motor's FLC for different types of protective devices, such as fuses and circuit breakers. NEC Section 430.109 covers motor disconnecting means. It specifies the requirements for disconnect switches, circuit breakers, and other devices used to isolate a motor from its power supply. When sizing conductors for a motor circuit, you must consider the motor's FLC, the type of insulation on the conductors, and the ambient temperature. NEC Table 310.15b16 provides ampacity ratings for various types of conductors based on their size and insulation type. Overcurrent protection is essential to prevent damage to the motor and conductors in the event of a short circuit, ground fault, or overload. The overcurrent protection device should be sized according to the motor's FLC and the requirements of NEC Table 430.52. Disconnects are required to provide a means of safely disconnecting the motor from its power supply for maintenance or repair. The disconnect should be readily accessible and capable of interrupting the motor's locked rotor current. Fuses are current-limiting devices that interrupt the flow of current when it exceeds a predetermined level. They are typically used in applications where high fault currents are expected. Circuit breakers are electromechanical devices that automatically interrupt the flow of current when it exceeds a predetermined level. They can be reset after they trip, making them suitable for applications where occasional overloads are expected. When selecting between fuses and circuit breakers, you should consider the specific application, the expected fault current levels, and the desired level of coordination. Coordination refers to the selective tripping of overcurrent protection devices. The goal is to ensure that only the device closest to the fault trips, minimizing the impact on the rest of the electrical system. In some cases, fuses may provide better coordination than circuit breakers, particularly in high fault current situations. However, circuit breakers offer the advantage of being resettable, which can reduce downtime. Ground fault protection is designed to detect and interrupt ground faults. It is typically required for large motors and in certain hazardous locations. Ground fault protection can be provided by ground fault circuit interrupters, or GFCIs, or by ground fault relays. Single phasing can be a significant problem for three-phase motors. When one phase is lost, the motor will continue to run, but it will draw excessive current from the remaining two phases. This can cause the motor to overheat and fail. Fuses can provide effective protection against single phasing by quickly interrupting the current flow when a phase is lost. Motor starters are used to control the starting and stopping of motors. They typically include overload protection to protect the motor from overloads. Motor starters can be manual or automatic. Manual starters are operated by hand, while automatic starters use contactors and relays to control the motor. Variable frequency drives, or VFDs, are used to control the speed of motors. They can also provide overload protection and energy savings. VFD are becoming increasingly popular in industrial applications. Power factor correction capacitors can be used to improve the power factor of a motor circuit. This can reduce energy losses and improve the efficiency of the system. Harmonics are unwanted currents and voltages that can be generated by nonlinear loads, such as VFD in electronic equipment. Harmonics can cause overheating of electrical equipment and can interfere with the operation of sensitive electronic devices. Harmonic filters can be used to reduce the levels of harmonics in a power system. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning strikes or other events. SPD should be installed at the service entrance and at sensitive electronic equipment. Regular maintenance is essential to ensure the proper operation of motor protection systems. This includes inspecting overcurrent protection devices, disconnects, and motor starters. It also includes testing ground fault protection systems and surge protection devices. Proper documentation is essential for all motor protection systems. This includes drawings, specifications, and maintenance records. The documentation should be readily available to qualified personnel. Safety is paramount when working with electrical equipment. Always follow safe work practices and wear appropriate personal protective equipment, or PPE. Never work on energized equipment unless you are properly trained and authorized to do so. Before working on any motor circuit, always de-energize the circuit and verify that it is de-energized using a voltmeter. Lockout-tagout procedures should be followed to prevent accidental re-energization of the circuit. If you are unsure about any aspect of motor protection, consult with a qualified electrical engineer or electrician. They can provide guidance on selecting the appropriate equipment and ensuring that the system is installed and maintained properly. Remember, motor protection is a critical aspect of electrical safety. By understanding the principles of motor protection and following the requirements of the National Electrical Code, you can help prevent damage to equipment, reduce the risk of electrical hazards, and ensure the reliable operation of your electrical systems. Consider the specific requirements of your application when selecting motor protection devices. Factors such as the motor's horsepower, voltage, and FLC, as well as the expected fault current levels and the environmental conditions, should be taken into account. Choose devices that are appropriately rated for the application and that meet all applicable codes and standards. Install motor protection devices according to the manufacturer's instructions and the requirements of the National Electrical Code. Ensure that all connections are tight and that the devices are properly grounded. Test motor protection devices regularly to ensure that they are functioning properly. This includes testing overcurrent protection devices, ground fault protection systems, and surge protection devices. Keep accurate records of all tests and maintenance activities. Train personnel on the proper operation and maintenance of motor protection systems. This includes training on how to de-energize circuits, how to test devices, and how to respond to emergencies. Emphasize the importance of safety and ensure that all personnel are aware of the potential hazards associated with electrical equipment. Regularly review and update your motor protection plan to ensure that it remains effective and compliant with current codes and standards. This includes reviewing the selection of devices, the installation procedures, and the maintenance practices. Make any necessary changes to improve the safety and reliability of the system. Consider using advanced motor protection technologies, such as intelligent motor controllers and predictive maintenance systems. These technologies can provide enhanced protection and monitoring capabilities, allowing you to identify and address potential problems before they lead to failures. Stay informed about the latest developments in motor protection technology and best practices. Attend industry conferences, read technical articles, and participate in online forums to learn from other professionals in the field. By staying up to date, you can ensure that your motor protection systems are always state-of-the-art. Remember that motor protection is an ongoing process. It requires continuous monitoring, testing, and maintenance to ensure that the system is functioning properly and providing adequate protection. By investing in motor protection, you can protect your equipment, reduce downtime, and improve the safety of your electrical systems. By following these guidelines, you can ensure that your motor protection systems are effective, reliable, and compliant with all applicable codes and standards. This will help you protect your equipment, reduce downtime, and improve the safety of your electrical systems. Finally, always prioritize safety when working with electrical equipment. If you are unsure about any aspect of motor protection, consult with a qualified electrical engineer or electrician. They can provide guidance on selecting the appropriate equipment and ensuring that the system is installed and maintained properly.